Good. So my name is Peter Schwenda, and together with Mubashar here from Tartu, we worked in a challenge area 4. We don't propose new blockchains. We just use them from various points of view. So I will describe 4 main usages. One is focused on using blockchain as a way how to enforce integrity of something. In our case, data that is collected through the digital twin and observation of the attacker's action. That's one thing. Or we are looking what is happening there. In our case, again, coin-join privacy-enhancing transactions that are happening on a Bitcoin blockchain. Or we are dividing techniques and tooling to analyze hardware wallets and other cryptographic devices that are used to typically protect the keys that are used within blockchain. And finally, we sometimes put everything together and build something atop of blockchains with help of zero-knowledge techniques, plus some secure hardware to harden the tools that are used there. Okay, so the first mini project. Here, the idea is we like to catch the criminals. We like to figure out how they are doing stuff. And we like to make it so that it can be even like forensically used later on in a code. So we will first create a digital twin. This is done also in a proof of concept with Microsoft Azure Digital Twin tool. And then we are observing what is happening there. Everything is stored for integrity purposes with the help of Ethereum blockchain. And that's the result. If you're interested more, we have some papers. So just take a look, read them. We also have tools, which is an open source tools. This is true both for this one as well as all others. Okay, we are not doing any proprietary software. We are having everything open. We do typically also cooperate with master and bachelor students. So a lot of work and hard work is actually done by them. So this is the first one where we are using blockchain for integrity purposes. The second one is where we are looking what is happening there. So despite the wide belief, Bitcoin is neither completely anonymous nor completely transparent. You can get the privacy there, but it's somewhat elaborate. You need to typically go into some elaborate cooperation with other people, creating together one big transaction that will give you privacy. And this is called coin-join. There are various protocols. A lot of money is like mixed and let's say protected via these mechanisms, but it's not very clear what is happening there. So we are proposing techniques, we are proposing tooling to understand this ecosystem better. We are not only proposing how to look at that and get some sense of it, we are also proposing how to make the conjoins better. So they are more efficient, they are providing you with better functionality, you better understand how much privacy you are getting, and so on. We do have, again, publications because we are researchers, but we are also having tools, both tools you can run locally on your machine and get some ideas out of it, as well as a web page where you can just take a look and peer what is happening there. If you're interested, the link to the web page is not here, but just talk to me. So that's the conjoin thing. Another one revolves around putting everything together and try to build a system that is having some nicer properties. In this case, we are putting together zero-knowledge techniques plus blockchain plus cryptographic hardware to get the system which is very easy to use. Users just don't need to have anything else than the ability to connect to their Google account. And then based on that, we can do all the heavy lifting and get them digital wallet and related operations. So that's the first part. The second part revolves around how to test devices that are used to protect private keys. These devices are typically very secure. We have Tropic Square guys that are making open source chip that is now embedded in a hardware wallet, which is something that was not done before. I like to highlight this. I very much like it. There is one problem with these cryptocurrency hardware wallets. They are not built to be automatically tested. And that's on intent, because if they can be very easily controlled from a computer for the testing, that can be also very easily controlled by a malware to steal your keys. Okay, so they are intentionally built that you need to physically press some button and touch here and read there. So for that, we built a dedicated device, a dedicated robot that is automating steps with the wallet and doing the operations there. We also know that no matter how much you will try, your device will have implementation flaws. So it's better to have 2 devices, so the attacker needs to find the flaws in both to be successful. Okay, so for that, well-known threshold cryptography, in case of blockchains, typically ECDSH signature, done in a multi-party way, when you have 2 people or 2 devices creating a signature. That's well-known technique, like people are researching this for quite some time, and it's quite efficient, as long as you have a laptop or mobile phone, very powerful devices. But what if you would like to run this on a smart card? That's tricky, because smart card is very limited with RAM, very limited with computational power. So we actually, because we love smart cards and we are working with them for a long time, we spent non-trivial time to figure out how to do it. I will show you on the last slide, on the next one, how it's done together with the people from Estonia. We have some papers, we have some implementations. Again, this is the robot I was mentioning. So you can't maybe see it, but the white stuff in the middle is a hardware wallet, and the robot is pressing, and the robot is reading and OCRing what is there and pressing again and so on. And this way we were able to generate 100,000 wallets and look how they are dealing with entropy and so on. Good. So finally, one selected highlight. So this is work we did with Cybernetica, more specifically Peter Laut on the cybernetic side, on our side, Antonin Duvka and me. This work started thanks to chess. Antonin was coming here, he was chatting with Peter, and together they figure out there is a protocol they can adapt and tweak and improve, so then it will run on very limited smart card. There is a research publication if you are interested, but there is also open source implementation of that running on a smart card. And then Antonin started as a Cybernetica employee, and we are also talking with another company that they will like to include this into their product. So this is something that I think is having all the components we are talking within the chess about. So I'm very happy about that. And that's all from my side. Thank you.